using generics in Go. So generics is has been it's been used mostly in collection framework. If you're familiar with the other programming language like Java and C++. Um, so there's a lot of requests in the Go community, and this is the top request functionality to be added in Go, and now it's here. Yeah, and it's just in version 1.18. So basically, you need to have this version in order for you to use this. So I just downloaded it in my local machine, and yeah, went through a little bit of the release notes and docs. So we can go ahead, and what are the things that are the changes for this release version. Yeah, so I'll probably go through this summary. These are the additional functionality that you need to know when you're using generics in Go. So generics is also known as type parameter, right? So in Go, previously, let's say if you have a function and you want to iterate a particular slice, let's say k-int, then you just have the function slice. You have to declare all the types here, int, if you want to iterate integer slice. So for example, you have to do something like this for I range, and then you call the function which is I, right? Basically, not uses. That's how you basically iterate the slice and call your function here. Now, if you want to do for the long, you have to create another one, which is so this is how you normally do this, which is I would say it's a bit troublesome. For each type you have to do something like this, right? And yeah, when you want to execute this, you do something like sets that print int, say I function print this is a okay. What's this? Let's try to run it. Okay, 0. That is printing the position, which is I. Okay, we just put post here in V. int64. If you want to do a long, to do another one which is long, yeah. Then you do a int64. Actually, yeah. So this is the way you previously do it. For each of the method, you have to create your separate type. It's not a type parameterized. So that's where the generics comes in to help us with this. Okay. So yeah. So how do we convert this to a generic function? So we go with what we call type parameter. How do you declare type parameter? So could convert it to something like this: iterate, put a bracket here, then your type t int, type t int, you convert this to t. In this case, you have, yeah, your constraint is still limited to int, but if you want to make int or int64, you could do something like any. So you could do something like this. Then we can remove this. The single function name that has different, multiple different types, depending on the one that you pass. Yeah. Any is similar to interface, the generic interface in Golang. If you're familiar with generic interface in Golang, any is similar to interface. Yes, which allow you to use different types. So for this case, you could do something like this. Yeah. You can still run it. Yeah, it still works, but we just use type any. So it's a replacement, an alias, I would say. Now we go with comparable. Comparable is another, so anything you put inside this square bracket is a constraint. Like, it limits what are the types that you want to put in here. So for this, it's like interface, like this is just generic interface type, which is can be anything. Now, what if we want only those comparable ones? So in version 1.18, there's another keyword called comparable, which allows you to only those types that allows you to have the comparison, which is equal, and so you can do something like this: if v equal, but if this is an any type, you cannot just compare it. So you'll see an error here because you can't compare that one to here. Yeah. So any is anything, then comparable allows you to use the comparable, allows you to use the equal method to compare. Yeah. So let's just try to run it one more time. Yeah, there you go, it's working. Let's just put 1, 2, 3. So you could see that we're printing each of the line. Yeah. So let's talk about constraints. So both of the comparable and any are constraints, but if you want to use your own like custom constraints, you can define it using a type. Let's say integer. This is your int, and then type integer, type interface. Then you can put it here. So this means that the constraint now are all int type, right? So when you run it, yeah, it's int 64. Okay, let's go back here. See, now it doesn't allow you to, because int 64 is not included, so you have to use int and int. There you go. What if you want to use int 64? So now they allow you to use a union, which is int 64. Pipe means union, that you could use int 64 and int for this integer type. So when you go here, you could now declare int 64 here, and then int 64, this will work. Yeah, there you go. So that's a type constraint. Now, what is this apostrophe? Like it's a tilde. Tilde allows you like approximate, right? If you do something like this and like this, it means any type that is declared as int or int 64 you could use. So for this example, like if I declare like type me is int, you can now use me here. Now it works. But if you don't put a tilde there, if you don't put a tilde there, it doesn't allow you to, because it's purely that this is an alias type, right? Pointing to int. So you have to put a tilde here to allow that to work. Allow you to use the me, okay, or whatever custom type that you have that points to t. Okay. Okay, so let's talk about type declaration. So that is type declaration, the one that I'm showing you right now. This is an interface, right? This is a constraint. So type declaration is you declare the type. Let's say normally you declare something like this: set int. This usually is not allowed in Golang before, because normally you can only declare something like var set int. That's how you normally declare it, as a variable, not as a type. But now in 1.80 you're allowed to do a type declaration, which is like this, and it also allows you to put generics on top of that. So for example, we're gonna implement a set, right? Set is like, you normally has a map. It's a map, right? With an int, and then struct. Yeah. But if you want to make this as a generic set, you could, what you can do is declare this as t, and then put a bracket here as t as type of integer. Okay, so now we can implement multiple set method with just the add, contains, and what else? Add, contains, and remove. Yeah, let's implement those three. So in this case, let's say I declare this my map as like this one, and I want to convert this now to convert my iterate to iterate the set. So this is, instead of declaring as an array of t here, you can now use this set t here. And then no, it's no longer for range because it's a hash map. So it's get a value, be okay. V is a value. So when you create your map, it won't be like this. It will be like set or like map. Int struct. Yeah, we can declare it like this. And then set is like that. My set. Put it here, then remove this. So my set is like the keys are 1, 2, okay. Yeah, I can do something like this. Yeah, so there you go, we're printing the set. Okay, let's try to do some add function inside the set. So add, you do declare something like this, add your set as set, make it as a reference, set t, and then you add an integer which is t. S is equal, no, S T is equal to here. Yes. Yeah, so you can actually do something like this. Yeah. How about contains? Contains is we check if square comma okay s turn boolean. Then return bool. Okay, return okay. Check the key, which is T. Remove is trying to remove this. Delete as with the T. Yeah, there you go. And then we create a constructor, which is something like this. Yeah, we can create a constructor which is function new set, which is type int, no, type T integer, which is just returns type new set here, which is set T. Make yeah. So in this case, instead of creating like this my set, you don't declare it like that. So we create for my set let's declare the type, which is int, or let's just create new set, sets dot new set. There you go. And then my set, okay, let's try to add some value. My set that add 1, add 2. There you go. So yeah, this is how you create generics. The most basic one. This is like, okay. How about we compare? Well, let's check if the contains now my set that contains 1. Let's check if my set contains 1, right? fmt.print. Yeah, it's true. So it's there. Let's try 3, just to confirm that it's actually working. Yeah. Okay. Yeah, there you get it. So there you have it. We covered most of the basic stuff in Go about using generics. One thing to note that about this is there's a few more features that you go here. I was looking at the constraints. There's a constraint package which is not yet added here. So you could actually use this integer. Like they use this integer is a union of sign and a sign, which is a sign, which is this. So instead of sign, you can use the sign interface instead of using this integer interface here. Right? You can use the sign interface. Then you can replace it here. Yeah. But it's on the experimentation, and then there are more additional functions added in the slices. Yeah. Index, grow, sort. Very useful function when you're dealing with slice. This normally we use the sort in the sort function. It also has a sort there. But if you wanna, like, even the map has keys added here. Yeah, you can go through it. Go through it for a quick one, and like trying to figure out which are like, you know, which are the proposal doc part has more of the yeah, this is more detailed one of how you use this thing, like yeah, yeah. There's a constraint any, yeah. You can also use multi-type parameters, like 2 parameters instead of 1, because I'm using 1 here. But your set can have like 2 parameters for your, let's say for your struct. KV, which is a struct type. Yeah, let's just declare as struct type, and then here you just declare this as a v, right? And then here you need to put here. But normally it's set doesn't need it. Yeah. And then you have to put v here. Yeah, but additional stuff you have to put v here. You have to put v here. Okay, let's try to put a v here. V struct type. Let's try to create an alias for this set. Let's call set2. Set2 is equal to set, which is t integer with struct. And struct type. I can't be a constraint, so you need to put this into, yeah. So this is set2. One. I'm gonna remove this. Yeah. So if you want to know more about the more detailed version of like what it can do, what do you need, you could go to this proposal by parameters. Has all the stuff that you basically, you can even also okay, I'll probably talk about in terms of struct, because we're talking about constraint in terms of this specific one. What if we want to create a set of a struct with this type? So you could create also a type of struct set struct with type integer, and then struct, and inside the struct is you put your t set t here. Declare yours. So instead of using a type, you could create a struct, and then you could add more variables here, like length, in, all stuff, right? Let's check. Check for struct. Yeah, you could just do something like this. Additional, if you want additional, instead of just a map, you want some additional fields. Like, yeah, you could do it something like this, because if you need additional fields for your type, you might want to consider create a struct for that. with additional field, and just because for this one it's just a map, right? Right. Yeah. Yeah, so that's it. That's mostly what you need to basically learn. If you wanna know more, you could check this documentation about it. Yeah. Thank you for watching. And if you like this video, this short video, you can hit like and subscribe. Yeah. And thank you, and see you again. And